Good afternoon, everyone. In today's video, we're going to actually dissect the anatomy of Schrodinger equation in connection with formula of everything. So in this particular video, which is going to serve as the part 2 of the previous video, I want us to dissect the happenings beyond the boundary. Just like in the previous video, we said that uncertainty principle has set a particular boundary that we can use to gauge, the solution that we have by using formula of everything. Now, the happenings beyond that boundary is much more than what we can, model with our current mathematics. And so in this video, I want to try as much as possible to explain it in such a way that we'll be able to understand. So now, with no further ado, let's dive into it. So now, this is the Schrodinger wave equation. In the previous video, I have explained, every portion, every part of this equation. So now we move straight down to this particular spot. Here you can see that I have changed this value from 7.5 times 10 raised power minus 48 to 5.7. That is the actual, suspending value when you substitute electrons mass worth in the formula of everything. So now, what I wanted to pay attention to is, here I say that this value is greater than this particular value. By the standard of negative power of standard form, we know that this particular value is lesser than this value. Okay, so now the law that can actually ensure the visibility of virtual particles says that we should always have our value to be lesser than this, lesser than the boundary of uncertainty. So now what I want you to see is that when you look at this value, you can see that this value is 1000 times bigger than this particular value. So this value is bigger than this. But now, how can we model this according to the happenings beyond this boundary? Beyond this boundary, we see that by substituting the wave amplitude as we have here in the formula of everything, we have this particular value. This value, if you compare it to this, you can see that we have mass convergence